When I entered college, I was a member of a large group of students known as undeclared majors. Like many of the others, I was in love with too many subjects to just choose one. My subsequent decision process wasn't unusual by any means, but something that made my experience unique was what I took from the advice that I got along the way. After my first year, I decided I really liked two things: writing and brains. So naturally, I narrowed down my career choices to journalism and neuroscience. My school technically didn't actually have these majors though, so I needed some advice. What should I major in? What would my career path look like? And was there a way that I could combine the two? My first stop in my search for answers was my journalism mentors. I think I got a pretty wide range of opinions here, but something was consistent in most of the feedback. When I asked them what I should major in or what they majored in, I tended to get the same responses: political science, international relations, history, English, American studies. Now this makes sense. Most of journalism takes place in the realm of law and politics. You need to understand the workings of governments in order to be able to report probably a good 80% of the news. But notice one thing: these are not scientific areas. Political science is a social science. And while there's a lot of really important research going on in all of these fields, none of it will teach you how to read a chemistry paper. Well, okay, even chemistry will barely teach you how to read a chemistry paper. But even the methods, the results, the entire research process is drastically different. So if most journalists study one of these 5 fields, where are they going to learn how to judge whether or not certain scientific results are credible? What happens when they're faced with results that, if true, could be a scientific breakthrough? I found a different trend on the opposite end of the spectrum when I talked to my neuroscience mentors. It was, it's really exciting when you get to do the research that interests you. Unfortunately, there's a lot of writing involved. Unfortunately? Wait a second, do so many scientific academics really hate writing that much? Writing and publishing results is our way of communicating our research to the world. So what does it say about scientists if they don't enjoy communicating their research? In case you're wondering, I graduated last year with a major in cognitive and brain sciences and a minor in mass communications and media studies, and I worked with the student newspaper, so a fair balance, I think. Anyway, so scientists don't really write and journalists don't really science. What this is leading up to is a problem that I've found almost every day when trying to read the news or scrolling through my Facebook feed. It looks a little something like this. Let me read these out. Scientists prove you can eat your way to a sharper mind. Scientists prove hologram theory could be true. Scientists prove cannabis does not make you dumb. Okay. Scientists prove that telepathic communication is within reach. That's pretty cool. German scientists prove there is life after death. What? A more recent example of this actually came up as I was preparing for this talk. It looked like this. Ham sausages cause cancer. Red meat probably does too, WHO group says. Which is particularly funny if you actually read the report. It says that the working group concluded that there is limited evidence in human beings of the carcinogenicity of the consumption of red meat. Meaning there is limited evidence that red meat causes cancer. I suppose limited evidence was enough for NBC to write, probably does. But the definition of limited evidence on the WHO's website is that a positive association has been observed between exposure to the agent and cancer, but that other explanations could not be ruled out. In other words, red meat could have been the cause of cancer, but they can't really say that it wasn't something else. This is probably related to a lot of other health-related articles you've seen, which include what to eat, what not to eat, what makes you fat, what causes cancer, or diabetes, or autism, or Alzheimer's. Red wine and chocolate, 2 of my favorite things, usually make it onto both good for you and bad for you lists, so I don't know what they want me to do. Many of these claims are unfounded, uncertain, or sometimes just plain wrong. And most of the time, though not all, the most harm that they do is introducing weird new food fads or shaming people about their diet. But they're also part of a larger problem, that I like to call bad science journalism. This happens in a few ways. One is when flawed or incomplete scientific research is reported in the news as fact. Another is when good scientific research is reported incorrectly. So far, we've seen relatively innocent examples of bad science journalism. But now let's look at what happens when it gets worse. This example hits a little closer to home for me because it's from my field of neuroscience. I read about this story in my favorite neurocriminology book called The Anatomy of Violence. In 1993, a group of researchers in the Netherlands looked at the genotypes in a single family in which many of the males born to females within the family were extremely aggressive. The genetic abnormality that the researchers found in these men was in their MAOA gene, which produces MAOA, or monoamine oxidase A, an important enzyme that helps to break down neurotransmitters in the brain. If this gene isn't working properly, our MAOA levels get too low, and we might start to see some behavioral problems, like the aggression in these men. Along came another study in 2006 in New Zealand that found that the Maori people, the indigenous Polynesian people of New Zealand, had a higher rate of this gene than Caucasian people in New Zealand. There's also a stereotype in New Zealand that the Maori people, being indigenous, are somehow more aggressive or warrior-like. And so the headline for this discovery was, "Warrior Gene Blamed for Maori Violence." Now, wait a second, the MAOA gene is no warrior gene. Just because one group of people has a higher rate of this gene does not make them all more naturally violent or aggressive than any other people. After all, the rate of this gene is quite high in Chinese males, but we know from statistics, such as the relatively low rate of homicide in China, that Chinese men are not the most violent group of people on Earth. But the fact that this gene was previously associated with aggression in some people, combined with the unfortunate stereotype of the Maori, allowed the media to paint this picture. And unfortunately, this was just one instance of a series of articles like it. Naturally, these articles sparked outrage against the researchers, the journalists, and pretty much everyone involved. People accused many neuroscientists of being racist, saying that no one can naturally be violent. Well, the problem is that some people are naturally predisposed to violence. But contrary to what these bad science articles told us, this predisposition is not necessarily related to race. It does not necessarily mean that a person will become violent, and there is not necessarily a single gene responsible for it. Science suffered from this bad journalism because no one trusted these researchers anymore. It became very hard to find funding for this type of research, and careers were damaged. But crucially, so much important research has gone ignored just because some journalists misinterpreted some results. Now, I'm still young, and at this point, I have more questions than answers. Why do we still believe bad science articles? How do we write science right? How do we fix the system? I can't answer any of these questions, but I can do two things today. One, as a previous student journalist and a current researcher, I can tell you what I've learned so far. And two, as someone who's still relatively new to working in science, I can help guide you through some of the first steps that I found helpful in educating myself. So here's what I've learned so far. In my experience, I've seen three different causes of science journalism gone bad. First, journalists mess up. You were probably expecting this from the beginning because journalists mess up and we like to blame the media for a lot of things. And well, we should, because the media are the ones with the microphone. We need to hold journalists responsible for reporting the facts, not just the stories that will get the most attention. But I've also worked in the media, and I can tell you countless stories of the hardworking journalists, myself included, who get blamed for things that are really not their fault, I promise. Many media outlets actually cover science very well, and many, while not getting it completely right, put forth a valiant effort. So I wonder, how do we make it easier for them? Well, the second cause of bad science journalism is scientists. While many, probably most, scientists are happy to talk about their work, there are also many who feel they don't want to simplify it too much to explain it to the public. This is understandable. If you simplify your results too much, you don't give a complete picture of your findings, and that can almost be as damaging as inaccurate reporting. But if you want to educate people about your work, which is one of the purposes of research, then you should be prepared to explain it in a way that others will understand. Although, how does one find the balance between simplification and accuracy? And then sometimes, journalists and scientists come together and they're truly well-intentioned, but something gets lost in translation from jargon to mass communication, and fiction is spread like fact. Which leads us to the third cause of misinformation, which is, drum roll please, you. Okay, well, not you, but everyone. Every single person out there is responsible for the information that we spread. My question for everyone, though, is how do we convince everyone to make a greater effort to understand science? How do we convince everyone to care? And how do we make it easier for everyone to care? So now I would like to try to make it easier for some of you by sharing a few of the tools that I, as an aspiring scientist, use when trying to understand the scientific world a little better. Until we figure out how to write science right, it's going to take effort from all of us to judge for ourselves what's good science and what's bad. Years ago, I saw this chart from a blog called Compound Interest that concisely sums up 12 steps that everyone can take to learn how to correctly interpret scientific results. You should check this whole thing out later, but for now, I'm just going to go over the 4 that I think are the most important. We can call these the 4 C's: clickbait, conflict of interest, control group, and correlation. Clickbait, or as the chart calls it, sensationalized headlines, is the attention-grabbing, oversimplified headline that says something like, "Scientists prove there is life after death." Scientists don't prove things, they find support for them. That's important. Headlines always oversimplify, that's their job. But if something sounds too good or too bad to be true, I usually assume that it probably is. And then I go and I enjoy my red wine and my chocolate. Conflict of interest is hopefully something that you can find within the news article. In order to find this, I ask questions like, who funded this study? Do the authors maybe have any patents, affiliations, etc., that might influence the results that they want to see? If there's no conflict, great. If there is, maybe look to see if someone else has been able to replicate the results. A control group is part of the experimental design. Whenever you're testing on a group of things, people, plants, objects, whatever, you need to have another group of similar or identical things that don't get the treatment but are still measured. So for example, if you're looking at how quickly plants grow after giving them a certain type of fertilizer, you also need to measure the growth of another group of plants that are the same type and grown in the same conditions, but that don't get the fertilizer. That way, you can definitely say how much the fertilizer actually helped. Different experimental designs will have different types of controls, but there should always be some sort of comparison like this. And our 4th C, which I think is by far the easiest and most important rule to follow, is correlation. Correlation does not equal causation. That is, 2 variables that are correlated, just because they are, does not mean that one caused the other. A good example that I like to keep in the back of my mind is from my undergraduate experimental psychology class, where we learned about a study that found a correlation between house break-ins and chimney fires. Now, would you say that house break-ins cause chimney fires? Or that chimney fires cause house break-ins? The answer is neither. Both are just more likely to happen in the winter. So make sure the article that you're reading isn't drawing any extra conclusions about causation. So at this point, you're probably thinking, why science? There are a lot of other issues with reporting in other areas of reporting. To which I say, yes, there are, and they're important issues to address. But let me give you another reason why science reporting is important to me. When we don't have good science journalism, I think we stop believing in science. Look at the trends we have. So many people still don't believe that global warming exists, and even fewer believe that it's man-made despite the overwhelming evidence of it. And so we're not taking the steps necessary to save our planet. Many people still believe that vaccines cause autism, which has never had any legitimate support. And so many parents still opt not to vaccinate their children, leading to recent outbreaks in the US of measles, mumps, and whooping cough, which were supposed to be eradicated, gone, a long time ago. Would all this be different if our news outlets chose to focus more on the science behind these stories? So here's what I'd like to see moving forward. Like I said, I'd like more people to make more of an effort to think critically about the science news that they read. I'd like for scientists and journalists to be patient with one another. When I was an executive editor at my school newspaper, despite being a science major, I found it very difficult to find science-related stories. Part of this was my writers and my editors lacking an interest in the sciences. Part of it was scientists not coming to us about their work. It was difficult, but I found that the more I pushed for science articles, the more I received them. Would the same trend maybe perhaps work at a larger scale? Could news editors change our entire approach to science just by putting a little more effort toward that area? Maybe it's possible, maybe it's not, but I'd like to see us try. Thank you.